Okay, coordinates are 100 integrals, number 18. Now this question is very similar to the previous question, number 17. Instead of like a minus, a plus here, this time what's inside the square root is a minus. So what we need to do is, of course, strict substitution, but this time instead of letting x equal to a tangent x, or tangent theta, we need to let x equal to a sine theta, or x equals to a cosine theta. All right, so let's start with this question here. So first step, we let x equals to a sine theta. We need to prepare our integration, so by doing the substitution method here. So dx is equal to a cosine theta d theta. Okay, so once we've finished here, we can now just put everything inside. So that gives us integrate the dx on the top, as you can see here, is just equal to a cosine theta d theta. So we can just put a cosine theta, and let's just put a d theta towards the end. Just make this one look a bit nicer. The denominator is a sine theta, so it's like a sine theta, and we'll have a square root of a squared minus a squared sine squared theta. So hopefully you guys can see within inside the square root that a squared can be factorized out, and you get 1 minus sine squared. Alright, so let's just continue to do this question again. I do want to just cancel the a and a, so make this one a bit easier. So that gives us cosine theta here over sine theta, and what's inside, we factorize this one out, that becomes 1 minus sine squared theta d theta. Alright, so once you take this a squared outside the square root, you end up with just a. So now we can just put 1 on a outside. It's on the denominator, so it's 1 on a. Numerator still equals cosine theta. The denominator is equal to sine theta. And after you square root, so what's inside here is cosine squared theta. So, if you do a very simple calculation, you should be able to take the cosine squared theta out. So that gives you this. Okay. Alright, so the next line of working out, it's going to be very straightforward. So you've got sine theta multiplied by cosine theta. And as you can see, you can cross these two out. So you end up with a very similar term comparing to question number 17. So that gives you cosec theta d theta. Alright, so once you finish that, we're going to use the skills that we just learned from last question. We need to multiply both the top and the bottom by cosec theta plus cotangent theta. Alright, so we can use the logarithm integration to help us to do the question there. So cosec theta plus cotangent theta d theta. Alright, so after we finish that, it becomes 1 over a. If we expand the numerators, we're going to get this. Okay, that gives you cosec theta plus cotangent theta. Now, as you can see, I didn't put the sign in the middle, so I just wanted to tell you that, if you differentiate cotangent theta, you will get negative cosec squared theta. So what I need to do is putting a negative in the front here, and then if you differentiate cosec squared theta, you end up with a negative cosec theta and cotangent theta. So therefore, I need to put another negative here. So that means if I put a negative in the front, outside, it will cancel everything we have. All right, so that should work now. So that gives you 1 over a ln or log base e, absolute value of cosec theta plus cotangent theta, absolute value plus c. Again, this time we still need to replace the theta by x. So we're going to start from the very beginning. We know that x is equal to a sine theta. That's our substitution here. So if we move the a to the left-hand side, we get x over a is equal to sine theta. So now we can simply draw a right angle triangle. And we've done this so many times, so you guys should be very familiarized with this steps here. So that gives you a squared minus x squared square root. Okay, so from here we can now finally to do a substitution. The cosec theta here is the reciprocal of the sine theta, all right, which is a on x. So that's a really easy one to do. The answer which is a on x. So we've got a on x, all right. However, for the cotangent theta, if you pay attention to cotangent, that is 1 over tangent. So that becomes adjacent sides over the over the opposite sides. So therefore, that gives you square root of a squared minus x squared over x, and absolute value plus c. So this question is really similar to the one we just did before. Yeah, okay, that's it. Thank you. Thanks for watching.